Don't think about a clock. Too late. You're already checking time inside your head. That number you just imagined, it can't touch the past, can't hold the present, can't stop what's coming. So what is it actually doing? By the end of this video, you'll know the answer, and you'll understand why a single second, 1 second in 2012, was enough to break parts of the internet. The honest answer goes back further than you'd expect, 5,000 years further. Picture a man 5,000 years ago. He drives a stick into the ground, watches the shadow move, calls the movement time. He was wrong. He wasn't measuring time, he was measuring the angle of sunlight. Now picture a monk in medieval Europe. He fills a glass container with sand, flips it over, watches it empty, calls the emptying time. Also wrong, he was measuring falling sand. Now picture today, an atomic clock in a government laboratory, cesium atoms vibrating exactly 9,192,631,770 times per second. Scientists call those vibrations time. Same mistake, different technology. Every clock ever built, from a shadow on sand to an atom in a vacuum, measures something moving, something changing, and then we point at the movement and say, that's time. But here's what that means. Remove all movement, freeze every particle, stop every change in the universe. No clock can run. Not because the batteries died, because time, as we measure it, only exists when something changes. We're not measuring time, we're measuring change, and we've been calling it time for 5,000 years. Think about the number 24. You've lived inside it your entire life, 24 hours, every day, no exceptions. Now ask yourself, why 24, not 10 or 100? Because ancient Egyptians divided daylight into 12 parts and tracked the night with 12 star groups. And that decision, made by people in a civilization that collapsed thousands of years ago, became the skeleton of modern timekeeping. The 60-minute hour, the 60-second minute, that's Babylonian mathematics, a base 60 system used by a culture that hasn't existed since before the Roman Empire. At some point, those decisions stopped being choices. They became infrastructure, then law, then instinct. Now satellites orbit at precise intervals to maintain them. Governments hold international conferences to protect them, and your body gets thrown into confusion twice a year when a committee decides to slide the number by 1. There is no 24 in nature, no 60 in physics. You are living inside an inheritance nobody asked if you wanted. Here's what nobody tells you about Earth's rotation. It's inconsistent. Not dramatically, not visibly, but measurably, constantly. The length of a day shifts. Ocean currents pull on it. Atmospheric pressure changes it. The movement of the molten core affects it. A large enough earthquake can measurably shorten the day, which means today is not exactly 86,400 seconds long. It never was. And because of this, because our atomic clocks are more reliable than the actual planet, scientists have had to occasionally add a second to the world's official time. Not to your watch, to the global timekeeping system itself. On those days, before midnight, instead of the clock flipping from 23:59:59 to 00:00:00, there was a moment that technically shouldn't exist. 23:59:60. In recent years, Earth has been rotating faster than expected, so scientists are now discussing a negative leap second, not adding a second to the clock, but deleting one. A second that will simply not exist. Time will move from 23:59:58 directly to 00:00:00. 1 second, officially, globally, skipped. No one will feel it, which is exactly what makes it unsettling. In 2012, the world added a leap second, standard procedure, a single second inserted into the global clock at midnight. And then, Linux systems crashed. Reddit went down, Gawker, LinkedIn, parts of Qantas Airlines' booking system, a chain reaction spreading through interconnected servers that had never been designed for a moment that lasted 61 seconds instead of 60. 1 second. A single, unexpected second, and pieces of the internet couldn't handle it. Think about what that means. We've built a global civilization of such precise interconnection that when the clock produces a moment that doesn't match the model, the civilization hiccups, not the planet, not physics. Our model of time was off by 1 second, and that was enough. Your GPS is lying to you, carefully. Right now, somewhere above you, a satellite is keeping time. It has an atomic clock on board, extremely precise, and it's using that clock to help your phone figure out where you are. But here's the problem. That satellite's clock runs fast, not because it's broken, because of physics. The satellite is moving at high speed and sitting far from Earth's gravity. According to Einstein's relativity, both of those things slow time down relative to an observer on the ground. ground. The net effect: the satellite's clock gains about 38 microseconds per day compared to yours. 38 microseconds sounds harmless, but GPS works by calculating how long a signal takes to travel from the satellite to your phone. If the clock is even slightly off, the position calculation drifts. By 38 microseconds per day, uncorrected, your GPS would be wrong by roughly 10 kilometers every day. So engineers built the correction directly into the system. The satellite clock is deliberately set to run slow before launch, so that once it reaches orbit, the relativistic effects bring it back to sync with Earth. Every time you navigate to a coffee shop, the system compensating for the fact that time runs at a different speed in orbit than it does in your pocket. You just never had to know. You and the person upstairs are aging at different speeds. This is not a metaphor. Right now, if someone is on the top floor of a tall building above you, they are aging faster than you. Not by much, a few nanoseconds over a lifetime. Not something you'd ever notice, but measurable, real, confirmed by experiment. The closer you are to a massive object, to Earth's center, to its gravity, the slower your time runs relative to someone farther away. Einstein called it gravitational time dilation. It's one of the most precisely tested ideas in all of science. And it means this: time is not a river everyone floats down together at the same speed. It is local, personal. It moves differently depending on where you stand and how fast you're moving. When we say, it's 3 p.m., we're making a claim that requires agreement, a social contract, a decision to ignore the physical truth that 3 p.m. is not the same for everyone. What we call the time is not a fact about the universe, it's a negotiation. There's a version of this story where the clock is just a useful tool. We needed to coordinate, to agree on when, to synchronize millions of people across continents without anyone having to negotiate every morning. The clock solved that. It worked. But somewhere between the sundial and the atomic clock, something flipped. We built the clock to serve the day, and the day started serving the clock. Now you feel late, not because you missed something real, but because a number on a screen doesn't match another number someone decided matters. You feel young or old, not because of how you feel, but because of how many times Earth has orbited a star since the moment you appeared. You measure a life in years, productivity in hours, success in how much you compressed into a unit of time that was decided by people who are dust. The clock is real. The coordination it enables is real. The pressure it creates, the lateness, the urgency, the sense that time is running out, that part is a story we tell. We don't measure time, we count change. And somewhere between the counting and the living, we forgot which one was supposed to matter.